Hi everyone, my name is Candace Peacock and I'll be presenting gaze signatures decode the onset of working memory encoding. Question: can gaze dynamics be used to detect the onset of working memory encoding? We encode information into working memory all the time and use it to keep mental track of our lists, tasks, and goals. In this example, this person is searching their kitchen and encoding a list of soup ingredients into working memory. Some people have good working memory capacity and others don't. So if we can generate computational models that can anticipate when people intend to encode information, then these models can be incorporated into computers that can assist people with encoding, such as an app that launches a notepad, photo capture, or voice recording, which might reduce the likelihood of errors. Although previous work uses location-based models to infer working memory encoding intent, these location-based models are not practical with current technologies, as these models require a system to have knowledge of a user's environment, which relies on power-hungry cameras and computationally expensive computer vision models to track the location and identity of gaze targets. We instead propose to take a step back and use gaze dynamics to detect working memory encoding onsets, instead of location, to bypass these issues. To test whether gaze dynamics can anticipate working memory encoding onsets, we used a virtual reality task in which people navigated from room to room and searched for arrows corresponding to objects to encode into working memory. They did this 5 or 9 times until they recalled the objects. From there, we used the gaze data from when participants searched for the object up until they fixated on the object that they encoded. We use sliding window logistic regression, as this is lightweight and can operate continuously in time. Any windows where the last value contained a null class meant no anticipation of encoding. Any windows where the last value contained a true class meant anticipation of encoding. Now for the results. The x-axis represents model performance for each participant, and the y-axis is the area under the precision recall curve. And the red line is chance. Here you can see that the model performed significantly above chance on unseen test data for all participants, suggesting that gaze dynamics reflect the anticipation of working memory encoding. Future directions. This model needs to be tested in new settings to show generalization for everyday use, as it was only tested in one setting for the current study. Thanks for your attention.